This is EE104 lab number 3. This lab is about curve fitting. We're using different methods to fit a curve. So one of the section of this lab is polynomial curve fitting. So right here, I use Desmo to plot this graph. I take the coordinate, I put it in Python. So I'm using this coordinate, the graph from this coordinate, to plot the graph, and then use the method of curve fitting to fit the curve into that plot I get from Desmo. So you can see this module, there are different curves I'm going to fit into this curve here. So, and then here these are the colors of the curve that I'm going to fit into this line that I drew from Desmo. So this is the original curve that I plot from Desmo, X and Y coordinate, and then these are the curve I'm going to fit in them and the colors. So let's run this graph and see. Let's love this program. Let's run this program and see how it's going to, the output is going to be. So you can see here, this is the curve. So basically this curve has other curve that I fit in there. So you can see here it's about 1, 2, 3, 4 curves being fitted into this, but the yellow is the one that took over because it's the last one that I put in there. But this one line, there are 3 other colors behind it. So the curve was fitted into this. So this looked like a sine wave when you plot it on Desmo. But here it appears like that. So that's one of the sections of this program, of this project. So then we go to the second one, which is number 2, which is linear regression. So this is also a curve we're going to fit into linear regression. So we're going to I work on this code to be able to plot a curve that I will also fit another curve into it, so called linear regression. So here you can see here, so this is the number of dots needed to form the shape, or line needed to form the shape. This is the original shape I'm going to form, and then after that I'm going to here you use this line to size it the amount you want. If you want a lot of other curves, you just change this if we give you that. And this is the diagram if you want to get like a grade behind it. The grade on the curve, you use this line to change it. So this program has a lot of other programs, very interesting, you can use to be able to change the curve that you want. So this is the curve I'm going to fit into the original curve. So it's going to be red, and then here is the color of the original point that I'm going to connect. This one, color of the point, I'm going to connect all the dot. So I'm going to run this code to see what it displays for us. So you can see here, so this is pretty messy lines because it has a lot of curves so put together. So it gives us this. So the red one in here is my line that I fit into this curve. So this is like a prediction of a random numbers to be able to see how your prediction is going to be. So the red line is the one that I fit in there. So this was what the code is about. So curve fitting of linear regression, different curves. So you try to predict how your curve is going to fit in there. Okay, then after that, I have another section in this project. So basically, I use the same polynomial curve fitting to be able this one is about damping. It's about damping. So basically you're using sine wave to be able to damp it. So in this here you add the because we're using equation. The equation is t you can see beta, omega, and pi. So basically using the how can I call it, using the sine function or trigonometric function to be able to damp it. So here I'm using cosine here to be able to damp it. So cosine function doesn't start at 0. It starts from 1 and goes to 0 and then damped. So so here I define this is the number of damped, which is x0. This is beta, increase the damping, and this is omega. Then 2 pi, omega is 2 pi, and then of course the pi is going to be 0. So I use this function and put into here this equation. So this function is the cosine function I'm going to put here. Then cosine 2 pi, then it's going to be plus an angle. So the angle, I say the angle is phi, which is 0. This is phi is 0. So the angle here is 0. I say phi is equals to 0. I could change the angle as well. So then after that, I try to fit the curve in there. So I use this dot as my point to be able to sketch the graph for me. So also this graph, this before I put this information in here, I also plotted on Desmos to be able to get the same curve and plot it. So you can see here, these are the curves that I fit into that damping cosine function. So let's run it and see how this is what is gonna give us. So you can see this is just the final curve of what I did. So this the cosine, it started from where, it doesn't start from 0, it started from where, and then damped, into this. If you keep on going, it's gonna go to 1. Or yeah, it's gonna go to 1. The curve is gonna flat, or it's gonna be long. So you can see different lines. So in here I fit another curves into it. The original curve is the green. That's the original curve from Desmos. So from there I fit the curve number 2 and number 1 in there. So you can see. So this was what this particular section of the program is about, to plot a damping equation and then fit a curve into it. So that's what I did in here. So after that we have another one. We're going to number 4, which is the noise. So for the noise, I use the same equation in the linear regression to be able to, because it's similar. So to be able to add noise to it and then curve fit in there. So as I explained, so this is the color of the background, and this I use this dot to be able to create a line for me in here. So this is the curve fit showing the labels. So there's a label on it, it's going to show us, and then here we add noise. So this dot is the noise that I added to this function. This star is a noise I add to this function. So inside that noise, we're going to curve fit to see how it's going to work. This is the original color of the noise. Noise added, that's the color of it, black. So I'm going to run this program now to see how it's going to work and what we are expecting from this curve. Of course, this is the number of the point or the dot, the noise we needed. So I'm going to run this program right now here. Run. So you can see here. So you can see the noise on this side, and then the curve fit. I fit 2 curve into this one, the yellow and the red. So I fit it into that noise. So this is the other sections about to be able to fit a curve into a noise. So this is the code, and then another one we're going to do is multivariable. So now I'm going to use a lot of point, then I fit a curve into a random number. So you can see here, so here I make the curve more steeper. Basically, if I change this number, the curve is going to be more steeper. So here, if I change any number here, 12, 10, or 1, it's going to change the shape of the curve. The curve cannot be enlarged or small. So this is what the code is about. And of course, this is the data I'm going to plot in here. I'm going to through data generated this function. And then these are the curve that I'm going to fit into it: black, red, blue, green, yellow. So these are the curve I'm going to fit into it. But I try to create a legend so that we can be able to see different curves that are fitting into it. So let me run this code. So I'm going to run this code. So this is the output of this code. So this is basically the random number. This is the random graph. So the original you can see here, generated curve is the blue. You can see here from the legend. So from there now, or is somehow blurry, but the original is the generator curve, the blue. So these all other line here are added to it from 1 to 5. The yellow, the green, the blue, the red. I add all those other curves into it, so you can see where these curves are being added to it. So to be able to predict, and it's not exact, but somehow it goes with the flow. So this is this other program is about. And then so this is the curve fitting project about this lab. So, and then one more thing in this lab, there was also that we have to develop a game development. So the game we're gonna develop is the coin game. So the coin game, I'm gonna go here. So I'm gonna go desktop, and I'm gonna look for no, let me go here. Let me go to my download. I'm gonna look for the game somewhere. Okay, this is my download. Hopefully I'll find it here. This is the coin game number 4. Gonna develop. Click on it. Yeah, so you can see I saved this game here as coin collector, or I just cut it short. So I'm going to run this game, but before, let me go to the code again. So inside this code, my actor here is the hedgehog. I changed the actor as the program instructor. I have to change this. I changed my actor. It was fox, but I changed it to hedgehog. And then another actor is the coin. So this line, so is the width and the breadth of the playing area. So I'm gonna enlarge the playing area, change the number. It's gonna enlarge it's gonna increase or decrease the playing area. So that's what I did. So if you come here, the screen background, so I was able to change the screen background to blue. Originally it was green, but I changed it to blue. So you can see things that I did in those code. So this is basically like changing the length of the coin. So here I changed the actor. Oh, I made a mistake here. This has to be actor. Yes, so I let the actor move really fast. The hedgehog to move really fast. So I increased by 4 times to be able to move really fast. And then from there, the score here. So each time you locate the hedgehog touches the coin, this is going to increase the speed. So this is the amount of times you're going to play the game. You're going to play until 10,000 before the game's end. So this is all about this game. And then I'm going to run this game to see how. So unfortunately, I cannot run on Python. I cannot run it on the spider. So I'm going to go open my command prompt. So from the command prompt, I'm going to go here. I'm going to click here, CMD, because if I run it in in Spider is going to give me error. So from here I'm going to Python, then I put the name of the game, coin collector, that abbreviated.py. So now the game, I change the background to blue. So this is the game. So you can see I could play this game. I'm going to use the keyboard here. I'm going to use these arrows. So I'm going to, but the game is really fast. So I just touch one coin and it changes into 10. So I'm going to come again. Each time I touch that coin, my score is going to go up. See? So it changes by 10. So 10, 20, 30. Each time you touch the coin, it's going to go 10, 20, 30, 40. So that's this project about.